So today we will be learning about how to find the x and y intercepts of a linear function or a graph. So first thing, the x-intercept is the x-coordinate of the point where the graph crosses the x-axis. So x-axis. So if we're crossing the x-axis, what would the y value be of any point? 0? Positive? Positive or negative? Sort of. What if it was 0?
Then it's neither.
Okay. So that says the y value of this point is always something, right? So let's just look over here. So this is negative 1, 2, 3, 4. This is negative 4, 0, right? What's the y value?
0.
Okay. Over here, this is 1, 2, 3, 4, 5, 6, 7. This is 7, 0. What's the y value?
0.
So on any point on the x-axis, what would your y value be? 0. Exactly. So that's what we put there, 0. Always 0. I guess I should write it up too, so it's not just a do. 0. Okay. Now, so that was the x-intercept. The y-intercept is the y-coordinate of the point where the graph crosses the y-axis. So, same thing. Is 0, 3. X value is. So it's safe to say that all x values for y-intercepts are 0. I know. I'm just hammering it in. Alright, so to identify your intercepts from a graph, you guys want to open your books up to page 237. We'll do a little example. $237. Alright, we're going to do that check it out problem at the bottom of that page. So, someone tell me what it says.
Find the x and y intercepts.
Okay, so find the x and y intercepts. So just looking at that graph, where does that line seem to cross the x-axis?
Negative 3, 0. Oh, negative 2, 0.
Negative 2, 0. Okay, so Michaela said the x-intercept is negative 2. And then that's ordered pair, what did you say, Noah?
0.
Negative 2, 0. Okay, so those are two ways we can write it. We can write x-intercept is negative 2, and then we can write it as the ordered pair, negative 2, 0. Alright. Someone else tell me what the y-intercept is at.
Negative 3. Or positive 3.
Positive 3, you sure?
Yes.
Okay. So positive 3, or the ordered pair.
Or
0, positive 3.
0, positive 3. Exactly. Alright, so does everyone kind of understand x-intercepts? Mostly in y-intercepts. X-intercepts are when you cross the what axis? X-axis, yep. So an easy way to kind of remember which one is which, the x-intercept, you're crossing the x-axis, so keep those similar, and the same thing with the y. Y-intercept is when you're crossing the y-axis, okay? Alright, so next we'll be finding intercepts from an equation, and to do that we substitute 0 in for whatever. Find the x-intercept, sorry, substitute 0 in for y, and solve for x. So, with a neighbor, I want you guys to discuss why we would substitute 0 in for y if we're looking for x. So just quickly, with someone next to you, just talk about why we would substitute 0 in for y if we're looking for x. All right, go. It's really quiet. Or you can talk with Joss. You can talk to Cody.
Oh, yeah, you can get
And Aurora, you can talk to me.
Remember what they're supposed to be.
Well, make sure you include Aurora because she's in your group too.
Yeah, what are we supposed to
Okay,
do?
I'm just asking you to talk about why we're substituting in 0 for y.
Why would
Solve
this
it for
class?
x. Why would we do this if we're trying to find that x intercept?
Because that's where it starts.
I recommend that.
I don't know.
You probably recommended that for me. I did my homework like one time.
Yeah, probably.
Where are you looking at?
I think we have other conversations going on that should not be.
Yep. Alright, so I think everyone was discussing for time, and that was good. Sort of got off track. So just the second part, when we find the y-intercept, we substitute 0 in for x and solve for y. It's just the exact opposite. So on page 237, check it out. 1b, that is the equation we're given, negative 3x plus 5y equals 30. So for the first thing, we're solving for the x-intercept, right? So to find that, we just do what we are told to up there, substitute 0 in for y and solve for x. So we would rewrite this as negative 3x plus 5 times 0 equals 30.
We're supposed to solve it.
We solve for x, so we just bring everything down, negative 3x plus 0, because 5 times 0 is 0. And then finally we divide by negative 3. Negative 3 30 divided by negative 3 is
negative 10.
negative 10. So x equals negative 10.
So when we're trying to, so when it says x-intercept, does that mean we find x, right?
We are finding the value for x when it crosses the x-axis. So if x is negative 10, what would the order of pair be for this?
Negative 10, 0.
Negative 10, 0. All right. So the reason why we substitute 0 in for y to find the x-intercept is because what is our y value for every x-intercept? What do we say on our first thing we did in the note? 0, exactly. So for every x-intercept, your y value is 0. That's where the 0 comes from when we solve for x. Okay? All right, so now we do the same thing for y. So how would I rewrite this if we're solving for the y-intercept?
Negative 3, 0 plus 5y equals 30.
Okay. 0 plus 5y equals 30. And then you guys can finish it out. Alright, did everyone get the same y value that I did? Mm-hmm. 0.6, so ordered pair? Right on.
Mr. Conlon, could we go and put those points on this? Could you come over here, take a blue marker, and put those points on here and show them what they actually just found?
Mm-hmm. So we found our x-intercept to be -10, right? So where would I go on here?
Negative 10 on X.
Okay, so 1, 2, 3, 4, 5, 6, 7, 10. Right here, right? That's our x-intercept, and then our y-intercept is
Go upstairs.
1, 2, 3, 4, 5, 6, right there.
How many points does it take to make a line?
2.
Only 2. Could we draw a line right now?
Yes.
Yeah, we could. So what we found is the x and y intercept without the graph, right? But we showed the graph after to support that it would make a line for this equation. Are we, right? We agree? Okay, so when the graph is already given for you, you are identifying it from the graph. What are the x and y intercept? When you're just given the equation, you're finding algebraically by substituting a value in, the 0 in for either x or y, depending on which one you're looking
Is it
for.
always gonna be 0?
And will it always be 0? So when we're looking for the x-intercept, what will always be 0 in the equation? When we're looking for the x-intercept, what will always be 0 in our equation? The y value, always. Because we're looking for the place where it's gonna cross the x-axis. And what did you guys just identify a little bit ago? All the points on the x-axis have a y value of
0.
0. And we're just gonna keep saying this until you get it to sink in. Let's try it again. Every point on the x-axis has a y value of 0. Are you convinced of that? For sure? Think it'll ever change?
No.
Always gonna be that?
Yes.
Okay. Well, how about when we're looking for the y-intercept then? We're looking for a point on the y-axis where it's gonna cross the y-axis. What can we say will hold true for those points?
0.
What's 0?
X.
The x value is 0. So when we're looking for the y-intercept, we will always substitute
X for 0.
x for 0 or 0 for x is probably the better way to say it. We will always put 0 in for x and we will find our y-intercept. And then we will be able, what we're finding is where will this line cross both of these axes? So it's another method of graphing. It's another way to help us graph. Isn't this a lot easier than maybe making a whole table with 5 points? What do you think? Do you like this? I think it's one of my favorite ways to graph because I can just make those 2 and not have to find other ones also. Could these be in a table?
Yes.
Yeah, if you would have picked x equals -10, would this have shown up?
Yes.
Yeah? If you would have picked x equals 0 for your table, would this point have shown up? Yes, because remember we pick the x values and we get the y values when we're using the table method. Okay, so you're doing it algebraically. You gotta make that connection though to the graph. Don't leave them separate of each other. The graph and this all go together.
All right, so we can move on to the next page. Then we'll go to page 240, that's where the next problem is. So this one says -2y equals 3x minus 6. First thing I notice is that x and y aren't on the same side like they just were. Josh?
Wouldn't you add 6 to the other side, so you have something on the other side whenever you multiply -2 and 0?
So you say add 6 to both sides, add 6. So it'll be 6 minus 2y equals 3x, like that? Okay. But we still have x and y on different sides. So, could we do that? Could we work it out if they're on different sides?
Yes.
Mm-hmm. Certainly could. So, let's do the one that Josh came up with. So 6 minus 2y. If we're looking for the x-intercept, what do we plug in for whatever?
0. 0 for X.
0 for x,
0 for y.
0 for y. Okay, so 6 minus 2 times 0 equals 3x. Negative 2 times 0 is 0, so 6 equals 3x.
Put that in there.
Hmm?
Show subtracting 0 like you did.
Oh, yeah. 6 minus 0.
And then could you just step back a little bit because it's really hard to see on this side. You're so tall.
Yeah,
Okay, are you with us here, guys?
alright. And divide both sides by 3. 6 divided by 3 is 2. Alright. So what ordered pair would this be? 2, 0. Okay. Now we're on to the y-intercept. What do I do first?
So
Plug in 0 for x.
Right, so just choose 0 in for x this time. Alright. Alright, so we're still trying to solve for y, right? How do I do that? How do we solve for y?
You divide y, 2y, or 2 divided by 6.
No. You add 2 on both sides, don't
Add 2,
you? To 0 on both sides.
just 2?
2y.
Okay, so add 2y, both sides. So we'd have 6 equals 2y. Now y is almost by itself, so last step we do,
divide 2.
divide by 2, by both sides. So y equals 3. Alright. And this would be ordered pair what? 0, 3. Alright. So, Josh first told us that we should add 6 to both sides, and we did that. And we got an x and y intercept from her equation that she found. Could we have done it with the first way?
No,
Yeah.
Why?
well, it would be like a lot. Or it would just be the same thing as that. Like,
Not sure what you mean.
We could do what we did for y, but it'd be more steps.
Okay. Yeah, so we could find the x and y intercepts if we just left it the first way, right? But,
I think what they're, what we need to point out here is really this. If you're gonna rearrange it, it's really only useful to rearrange it, rename it, if you're gonna put the x's and y's together on the same side and the constant on the other side. Otherwise, you really don't accomplish much of anything. You did make it easier for finding the x-intercept, but notice it was an extra step to find the y-intercept. If you would have left it the way it was, it would have been easier to find the y-intercept, and it would have taken one extra step for the x-intercept. So the point is this. No, let's go back to the front side. Will you look at the front side, please? Were the x's and the y's on the same side?
Yes.
Was it pretty easy when they were on the same side?
Yeah.
Yeah. So what do you think? Do you think it would be best maybe when you're going to use this method to graph, or you're going to find the x and y intercepts, maybe to get the x's and y's together and the constant can be on the other side? Would that maybe be,
it would be easier, but it doesn't really matter.
it doesn't really matter though, does it? You can do it, and you can rename it any way you want, not even rename it if you don't want to. But if you do want to make it probably the most friendly, I would suggest you get the x's and y's together on the same side. So what could we have done on that number 2? One step, all we would have had to do to get the x's and y's together, what could we have done? Subtract 3x from both sides, right? No.
Add 2 y from both sides. So it'll be 6 equals 3x.
Oh, then we'd have to move the 6 also, wouldn't we? Yeah, so we could do that, we could add 2y to both sides, but then we'd also have to add 6 to both sides to get the 6 over on the other side, right? It would take 2 steps. So we could have done that, or we could just subtract 3x and we have everything being negative. We'd have a negative 2y, take away a 3x, equal to a negative 6. So we have options, in other words, okay, but you need to decide what's going to help you make it so it's gonna work well for you, so that it's friendly, okay?
All right, so last problem before we get to our assignment. So there's a whole lot of stuff going on there, isn't there? So just like Ms. LeGrand said, things are easier when they're grouped together. So how can we get everything together? So first things, let's get everything together to make it neater.
Can you get the X's and Y's together?
Mm-hmm. Everything together. All right, so how do we do that if we want to get the X's and Y's together?
Add 2y to 4y.
Add 2y, okay.
Subtract 2y.
Oh, okay, subtract, so subtract 2y. Okay, that gets rid of the y's. What about the x's?
Let's just do that first.
Okay.
Don't do it all in one step.
Okay. So those cancel out. 4 minus 2 is 2y. That's not 3. 5x equals negative 3x plus 16.
Add 3x to 5.
Okay, so we add 3x to both sides. Oh, I'm sorry. All right, so 5x plus 3x is
8x.
8x plus 8x. All right. So we got all the x's and y's together. Does it matter that the y is first?
No.
Nope, right? Because addition, it doesn't matter which goes first, right? 4 plus 1 is the same as 1 plus 4, right? All right, so now we have to find the x-intercept and y-intercept. Okay.
Okay, let's let them try this one on their own.
Yep. So our equation is right there, 2y plus 8x equals 16.
Could you scroll up just a tiny bit?
Yeah, can you, yeah, I need to see this.
There you go.
I didn't take it.
Let's get the equation here first.
Oh, that's it.
Hmm?
That's it, isn't it?
Oh yeah, now you're trying to find the x-intercept and y-intercept.
Oh.
work this one out. So for x-intercept, we substitute
0.
what? 0 in for y. Okay, so you rewrite it as 2 times 0 plus 8x equals 16. That's an awful percent. Okay, 2 times 0 is 0 plus 8x equals 16. 8x equals 16, because 0 plus anything is the same thing. 16 divided by 8.
2, x equals
2, exactly. So 8 divided by 8. 2, and what order of pair is that?
2, 0.
2, 0. Good work. So now we do the y-intercept. So we rewrite it when x is substituted in for 0, right? All right. Did everyone else get 8? Wonderful. And the ordered pair for this one is
0,
0, 8. So I plot these points on a graph. Where would the x-intercept be?
2, positive 0.
Right there. Then our y-intercept is
0, 8.
0, 8. So that is the x and y intercept for that graph. So if I were to draw a line for this thing, and don't judge me on my bad line drawing skills. Really bad, sorry. So that was what the line would look like for that graph. All right. So everything was a lot easier when we got x and y on the same side, right? Yep. So just when you're doing your homework, if x and y are on the same side, you don't have to, but it usually is a good idea to get them both on the same side because it's just a lot easier that way. Just as you avoid doing extra steps. So, does anyone have any questions about Joss?
How are you supposed to show your work on your homework?
Good question. So,
Like for the graphs?
for the graphs, for x-intercept, you just have to write x-intercept is whatever, and y-intercept is blank. Yep. And then for ones where you're asked to find the y-intercept, x or y-intercept algebraically, you just can have x equals